loose soil that was added to the back section, about 86%, with the remainder trapped alongside the boards and actually inside the Roomba itself, but not in the compartment that's intended to capture the particles. Here you can see the surface. In fact, the entire surface, you'll notice, has been discolored with a reddish tint. This is due to the residual fine particulate matter which was spread by the Roomba over the entire plastic sheet, including the areas not originally contaminated with the soil. Because if you will recall, the soil is only added to the back 1/3 of the plastic area, but yet you can see that it is actually it has been distributed over the entire area. Now, the effect of this is to significantly reduce the reflectivity of the surface from an estimated 0.8 to around 0.3 or 0.4. The explanation for this is mostly due to a set of rubber blades under the Roomba, which are intended to sweep large particles into the roller brushes where they are mechanically moved inside the vacuum cleaner and drawn in by the vacuum itself. Here's the underside of the Roomba. You can see what I'm talking about. These are the rubber blades, and they're completely covered with the soil. And so they're actually, even though these are very small particles, they're adhering to the rubber, and as the rubber blade moves along the surface, it actually ends up being spread all over the surface. The blade moves the particles all over the surface. The fine particles are too small to be swept up in this way, and as I said, the blade ends up carrying them along. The wheels also spread some of the soil and leave indentations in the plastic in which fine particles are trapped. And you can see that the tread on the wheels is also covered with the red material. Well, these features are appropriate for home vacuuming, and the Roomba designers did not intend for it to replace wet mopping of floors, which is how such a surface discoloration would have to be removed once it's in place. Let me show you, however, what wet mopping would do to the plastic that's been contaminated in this way. Wiping with a wet paper towel removes a great deal of surface material, which you can see is on the towel, and actually has increased the reflectivity of the surface considerably. So the material which was deposited by the vacuum cleaner from the back section actually can be removed by a wet mopping. So it's not permanently embedded in the plastic. What then are the design features of a GeoVac that would remove the deposited soil and dust without discoloring the surface and reducing the surface reflectivity? Well, such a vacuum cleaner would operate with a vacuum system only, and no rotating brushes or rubber sweeping blades that would end up contaminating and spreading the fine material around. The vacuum head would be located at the front of the GeoVac and would not touch the surface of the plastic. The wheels would consist of balloon tires to minimize compression and spreading of soil and dust over the remainder of the surface. As an example of how this would work, consider a traditional vacuum cleaner with a cleaning nozzle like this one. It removes the same soil deposited in the earlier demonstration, but won't leave tracks of soil or leave a film on the surface. Let me just demonstrate that. Here's a section of plastic which hasn't been contaminated. I'm going to place this down in the middle, move out of the way so you can see that that's a very clean surface right there, very, very bright and shiny compared to the what it is after contamination. Now I'm going to add some soil to that. And I'm going to vacuum that up. Well, as you can see, the surface is back to almost its original reflectivity. There's still some residual film left on the surface, but nothing like what we saw with the robotic vacuum cleaner spreading it around. So having only a vacuum nozzle removing the soil is actually probably going to be the preferable way of doing this. The alternative is to use wet GeoVacs, that is something like a wet mopping system, to remove the residual film. And this would greatly complicate the maintenance of the plastic surface. You know, you would have to perform the equivalent of a wet mopping of thousands of square miles of plastic ground cover. And because of the need to use water in the desert for this purpose, it might be impossible. One final consideration is to equip the GeoVacs with built-in albedometers so they can tell when the surface reflectivity has been restored to acceptable levels. They would be intelligent enough to know when to clean an area. There are many issues that will require research before large-scale surface covering with plastic can be seriously considered as a planetary band-aid, if you will, for global warming in the years to come. Ensuring surface reflectivity with robotic vacuum cleaners is one of the most important ones. This video was produced by Environmental Reference Materials Incorporated of Research Triangle Park, North Carolina, which is solely responsible for its content.